Okay, so our next lesson is on the remainder and factor theorems. So we're going to start out talking about polynomial division, and this can be accomplished by using one of two methods. So our first method is going to be long division, which is obviously going to be a little bit longer and more work. And then there's going to be another method that we're going to go over called synthetic division, which is much quicker and shorter. However, it can't be used in all situations. Now, just as a refresher, when you look at the terminology here, when you're referring to different parts of your division problem, the polynomial that's inside, this is the dividend. On the outside, you have the divisor, and then your answer is called a quotient, and it may have a remainder. So when we go through our polynomial long division, you're going to set it up in that format that I just showed you there. Now, this divisor here is a linear binomial, and that's going to go on the outside. And then inside this dividend, you're going to put this larger polynomial here that's going to be divided. All right, so now when we do our division, we're going to start out focusing on the first term of the polynomial in the dividend, and we're also going to look at the first term of the divisor. So we want to ask ourselves what number or what term multiplied by 2x will give us this 4x cubed? Or how many times can 2x fit into 4x cubed if you're thinking about it like in terms of division? So 2 times 2 would be 4, and x times x squared would be x cubed. So that tells me I'm going to need 2x squared. Now when I write that down, I'm going to write that on the top, and I'm going to try to line it up on top of any other like terms that are in that dividend. And now what essentially I'm doing is I'm taking this 2x squared and I'm multiplying it or distributing it to my divisor. And when I do that, I'm going to write the product that I get underneath here. So 2x squared times 2x will be 4x cubed. And then 2x squared multiplied by -3 will be -6x squared. Now, just like in traditional long division, you would have to subtract now. Well, I'm subtracting my 4x cubed, but when I subtract this -6x, it's going to become a positive. Okay, so now when I do those first two, they should cancel out. And then 2x squared plus 6x would leave me with 8x squared, like terms there. And then I would carry down that next term, which is the -2x. Now I would repeat that same process, but this time be looking at the 8x squared and figuring out how many times can 2x go into 8x squared, or what do I have to multiply my 2x by to get 8x squared. So I can figure out that that's going to be 4x, so I put that up on the top in the quotient. And now I'm going to multiply or distribute this 4x to the 2x minus 3 in my divisor, and that's going to give me 8x squared minus 12x. And of course, once again, we're going to subtract that, but we're subtracting every term, not just the first one. So while that's a minus 8x squared, this minus a negative will change that to a positive 12x. So when I do this now, the 8x's will cancel. -2 and positive 12 gives me 10x, and then I have to carry down the 6. So now I have one more step to do here because 2x can still fit into 10x, and I can do it by multiplying 2x by 5. And then, so now we're going to distribute or multiply that 5 to the 2x minus 3, getting me 10x minus 15. And now, of course, I would subtract each of these terms. When I subtract the -15, it becomes a positive. And then 6 and 15 would give me 21. So then my final answer, I would have this quotient up top, but I would have to add on my remainder over my divisor, and then this entire piece here would be my solution. This would be the quotient and the remainder. Okay, so let's try it again. All right, now when we look at this next one, this time our divisor happens to be a quadratic polynomial, a trinomial specifically, because there are 3 terms there. And then I'm going to put this larger quartic polynomial inside my dividend. Now you might notice that there's no x squared in this particular polynomial, so I'm going to use a 0x squared as a placeholder. Another option would be you could just kind of leave a little blank space. But if you don't put anything, it's okay. You could still do it. However, it's just a little more likely that you may end up combining unlike terms or something like that as we go through the problem. So I think it's just a little easier just to kind of help keep everything organized by putting in that 0x squared as a placeholder or just leaving a space there or something like that. It'll help you line up your quotient and everything a little bit easier. So now again, we're going to start out by looking at the lead term for both the divisor and the dividend. So x squared times what would give you 2x to the fourth, 2x squared. Now notice this is why it was really nice for me to leave that placeholder in there, because now I know where to line up my 2x squared. So now I'm going to multiply my 2x squared times everything in this divisor here. So it's essentially distributing. So 2x to the fourth, and then minus 4x cubed, and then plus 4x squared. Now we want to do our subtraction. Remember, you're subtracting not just the first term, but everything in this polynomial here. So this 4x that was a negative is going to become positive, and this one here will be a subtraction sign. So now what happens at this point are the first two should cancel. Then you have 3 plus 4, which is 7x cubed, like terms. And then 0 minus 4 would be negative 4x squared. And then, of course, we would carry down that next term, which is just that single x. So now we're going to look at the 7x cubed, and we're going to figure out what is the next part of our quotient. So what number or term times x squared will give me 7x cubed? And that's going to be 7x. And now we're going to multiply the 7x to this trinomial divisor over here. And we're going to get 7x cubed minus 14x squared plus 14x. And of course, now we're going to subtract. Subtract the 7x cubed, subtract the negative 14, which makes that addition there, and then this 14x will be subtraction. So the 7x cubes cancel. Then we have 10x squared, and then 5 minus 14 is negative 9x, and then of course we have to carry down that negative 1. And then we're going to go through this process one more time. X squared times 10 will give me this 10x squared here. So 10 times x squared. Then 10 times negative 2 is negative 20x. And 10 times 2 is 20. Again, doing the subtraction, making sure you're subtracting each and every term. So I have the 10s that will cancel. Negative 9 plus 20 will leave me with 11x. And negative 1 and negative 20 will give me negative 21 as the rest of my remainder. So my solution is this quotient here, the 2x squared plus 7x plus 10 plus my remainder of 11x minus 21, which always needs to be written as a fraction over that divisor. And then that would be my solution, this whole entire thing. All right. So moving on to number 3. All right, so again, I have a quadratic divisor. It is only a binomial this time, and the constant is not there, which means it would be 0. Now, if you have a constant that's missing, you really don't need to put a placeholder in since it's at the end. So I'm just not going to worry about that. Now I have 10x cubed plus 27x squared plus 14x plus 5. And again, we're going to start by looking at the lead terms of both of our polynomials here. So what would I have to multiply x squared by to get 10x cubed? And that would be 10x. And I'm going to line it up in my quotient on top of my other like terms there. Now I'm going to multiply it to the divisor. So 10x times x squared gives me this 10x cubed that I need. And 10x times 2x is 20x squared. Now I'm going to subtract. Make sure you're subtracting both terms. So 27 minus 20 is 7x squared. And then, of course, I'm bringing down that next term, which is just 14x. Now I'm going to use my 7x squared to figure out the next part of my problem. So what would I have to multiply x squared by to get 7x squared? Well, that's simply just a 7. And that will give me 7x squared plus 14x. Now this one, when you subtract both of these terms, they both cancel. However, you still have to bring down that 5, and then you end up with just a remainder of 5. So then that 5 simply goes over the x squared plus 2x, so you write it as a fraction over that initial divisor, and this would be our solution for this division problem right here. All right, and then we're going to do one more of these long division problems right now. Okay, so I have a quadratic divisor. Happens to be a trinomial. Then I put my polynomial in. Now this time I'm noticing that I'm missing an x cubed, so I'm going to put in that 0x cubed as a placeholder. Just help me keep it a little more organized. Plus, when you do synthetic, you have to put the zeros in. So if you're already in the habit of doing it, it won't you won't miss it in the synthetic. All right, so again, starting out with our lead term in each of these, x squared, we'll just need to multiply by another x squared in order to get this x to the fourth here. So now I'm going to multiply my x squared up in here in the quotient by both negative x and 1, giving me negative x cubed and plus x squared. And now, of course, we're going to subtract all these terms. So subtraction, that changes to addition, and then this one will be subtraction. So 0x cubed plus 1x cubed is just x cubed. 2x squared minus x squared is just x squared, and then we have to carry down this negative x. Repeating that process once more, we need to multiply a single x by the x squared to get this x cubed here. Then x times negative x would be negative x squared, and x times 1 is simply just x. Again, subtracting each of those terms, and if it's already a negative, it's changing to an addition. So now I have 2x squared minus 2x, and then we're carrying down this 5 here at the end. And this will be our final time through this. So 2 times x squared will give me this 2x squared, so I know 2 is the last part of my quotient. And then when I multiply that 2 by all three terms in my divisor, I'm going to get 2x squared minus 2x plus 2. But of course, all of those need to be subtracted. So I end up with a 3 as my remainder. So when I complete my answer, I have my quotient. I'm just going to add on my remainder, but make sure you're writing that as a fraction over the initial divisor, which was x squared minus x plus 1. So this whole piece right here would be my solution for that long division problem. Okay, so now you might have noticed that all of those problems, well, the last three all had quadratic divisors. And the first one that we did have a linear divisor, but it did have a coefficient other than 1 in front of the x. So all of these were problems where you would want to do long division. Synthetic division is much quicker and faster and easier. However, you can only use it when you're dividing by a linear factor in the form of x minus k. So you have to have just x plus or minus some other constant value. That's the only type of factor that you can use the synthetic division for. So for example, this would be a polynomial division problem that we could use synthetic division for because my factor is just a simple linear factor. Now the only catch is when you're using this substitution grid, we did that synthetic substitution, you have to realize that they're giving you the factor here, not what x equals. So you're going to have to account for that. And basically, you're just using zero product property to solve for that x value. And then once you know it's x equals -2, then that's really what we're going to use for our substitution grid. Same thing, though, if you remember from a couple lessons ago, You want to make sure that your polynomial is in descending order, and you're going to put those coefficients in. So the x cubed coefficient is +1. The x squared coefficient is -1. The x coefficient is -2. And then the constant at the end is just that +8. And then we figured out that we had to do this -2 in the front because you had to solve that factor, and you get x equals -2. Now, when you actually go through the grid, just as a refresher, you drop that first number down, which in this case is 1. You multiply it to that number out front. So 1 times -2 gives you this -2 we have here. Adding up the column there, we get -3. Multiplying to the number out front, we get +6. Adding up the column, we get 4. Multiplying to the number out front, we get -8. And in this situation, that last number is 0. Now, when we were doing substitution, we would be done at that point, and our answer would just be 0. However, in this case, this is representing our remainder. If we're going to use this as a division method, this is our remainder. Then going backwards in ascending order, constant is the number at the end, right before the remainder. The number before that would be your linear coefficient or your x coefficient, and the number before that would be your x squared. And if you had to continue, you would go on x cubed, x to the 4th, and so on. So you can see 1x squared is where we come up with this part of our answer. Minus 3x is the next term, plus 4. And then we didn't have a remainder, so that was our answer for that problem. So let's try a couple more. So for dividing using synthetic, the first thing we want to do is set up our little synthetic grid using our coefficients that are given to us and making sure, of course, that there's nothing skipped or we'd have to put in the 0. Then we look at the factor that they're giving us, and we have to solve it using zero product properties so that I know x will equal 2. And that's the number that's going to go outside. Then we can just use our grid pattern. So dropping down the 1, 1 times 2 is 2. Adding those up is 4. 4 times 2 is 8. Adding those up is 2. 2 times 2 is 4. And adding those up, I get -5. Now, we're not just doing substitution, so we're not done. The -5 represents our remainder. The 2 would represent our constant. The 4 represents our x coefficient, and the 1 represents our x squared coefficient. So we would then write our answer as 1x squared plus 4x plus 2, and then plus my remainder, which is -5, over my original divisor, which was actually x minus 2. Okay, number 2. So now this particular one, we know that this factor here is going to give us an x value of -4. So that's what's going to go outside of my little grid here. The coefficients, however, I'm missing an x squared if I look at this polynomial. So I'm going to have to put a 0 in the place where the x squared would be. So I have a 1, a 0, a -4, and an 8. Then I'm going to use my grid pattern, bring down the 1, multiply to that -4, put it in the next column, add it up. -4 times -4 is 16. Next column, add it up. And -4 times 12 is -48. And then when I add those up, I get -40. Again, that represents my remainder. The 12 represents my constant. The -4 is my x coefficient, and the 1 is my x squared coefficient. So I can write my answer, x squared plus 4x, minus 4x plus 12, and then adding my remainder, which is -40 over, written as a fraction, over x plus 4, because that was my original divisor right here in the original problem. Okay, a couple more. All right, so now for the next problem here, I'm going to take my divisor, which is x minus 7. So I know I'm going to put a +7 on the outside of my grid. I have a 1 and a -6, but then I have an x to the 2nd power that is not physically there. So I'm going to put a 0 in for that coefficient, -40 and 33. Using my grid pattern, I drop down that 1, multiply it by 7, add those up, multiply by 7, add those up. 7 times 7, 49. I'm going to add those up. and 7 times 9 is 63, and then I get 96. Remember, that is my remainder. The 9 would be my constant. The 7 is my x coefficient, and then this one is my x squared, and this one is my x cubed. Now notice this time, I ended up with an x cubed on my answer, but that makes sense because my original problem started with x to the 4th, and if I'm dividing out one of my x terms, my answer should always be one less. So the last two problems were cubic, and we divided one out, and we had x squares for our answer. So this answer then would be written as 1x cubed plus 1x squared plus 7x plus 9 plus my remainder of 96 written as a fraction over the divisor of x minus 7. All right, number 4. Okay, so again, my divisor is just going to be the -1 there. And this time I am missing the x term, so I'm going to have to put my 0 in that location. So my coefficients are 10, 5, 4. I'm going to put the 0 in for the x, and then -9. Using my grid pattern, dropping down the 10, multiplying it to -1, adding up the next column, multiplying, adding up, multiplying, adding up, multiplying, adding up. Now this time it just so happened that my remainder was a 0, but I still work backwards, kind of assigning all these numbers to the different parts of my polynomial answer. Constant, x coefficient, x squared, and x cubed. The fact that I end up with an x cubed as my lead term makes sense considering I had an x to the 4th and I was dividing one of the x's out of it. So my answer would be 10x cubed minus 5x squared plus 9x minus 9. And I don't have a remainder for this problem, so I don't have to worry about that. Okay, number 5. I'm going to have a positive 3 out front. And this time I'm missing both my x to the 4th, so I'm going to put a 0 placeholder there, and I'm also missing my x squared, so I'm going to put a 0 placeholder there. So I have 3, 0, 2, 0, -5, and +1. Now notice this one is an x to the 5th polynomial, so I suspect my answer will be an x to the 4th since I'm only subtracting or dividing one of the factors out. So using my grid, dropping down the 3, multiplying those, and I get 9. 3 times 9 is 27. Adding those up, 29 times 3 is 87. Adding those up, 3 times 87 is 261. Adding those up, and 256 times 3 is 768, giving me 769 as my remainder. This 256 is my constant, the 87 is my x coefficient, the 29 my x squared, the 9 my x cubed, and the 3 my x to the 4th. So this answer would be 3x to the 4th plus 9x cubed plus 29x squared plus 87x plus 256 plus my remainder, 769, written as a fraction over the x minus 3. Okay, and again, the synthetic division, obviously a little bit quicker and easier to do, however, can only be used for those simple linear factors. So with that in mind, let's review a couple long division problems. Now, even though this is a binomial here, notice my factor is quadratic, so I would have to do long division in this situation. So going back to our long division method here, my x squared plus 5 would go on the outside. And then in the inside, I have my x cubed plus 8x squared minus 3x plus 16. So if you remember from the beginning of the lesson, we're going to focus on the lead term in both spots, the divisor and the dividend. X squared just needs to be multiplied by another single x to get this x cubed. So x times x squared is x cubed, and then we also would multiply this x to the 5. Now this one's a little different because notice the missing term in the divisor, there's no just single x value. So when I do x times 5 and I get 5x, I want to be really careful to line it up underneath the other like term. If you wanted to make this x squared plus 0x plus 5 so that you don't mess anything up, you can certainly do that. It's not necessary, but it could be helpful for some people. Now I'm going to subtract any terms I have here, so both of these are going to be subtracted. The x cubes cancel. My 8x squared did not have anything to combine with, so it's just going to be basically written down again. And then the -3 and the -5 are going to be negative 8x. And then I'm going to carry down the next term. Okay, so now we're going to do the same thing, but we're going to focus on this term here. So x squared times what would be 8x squared? Well, of course, it would just be 8. So now I'm going to multiply 8 times x squared, giving me 8x squared. And then I'm going to multiply 8 times 5, giving me 40. And I'm just going to make sure I line it up with my other like term. So now I'm subtracting both of these terms. The 8x squares cancel. I'm left with negative 8x, and 16 minus 40 is negative 24. And that's my remainder because x squared can't go into 8x. So my solution here is x plus 8 plus the remainder, which is negative 8x minus 24, and that goes over my divisor, which is x squared plus 5. Okay, so then the next problem, again, another long division because this is a quadratic divisor, so I cannot use synthetic here. I have negative x cubed plus 2x squared minus 2x plus 3. So once again, my dividend, everything is in descending order. I'm not skipping any terms where I need to put in a 0. My divisor does not have an x term, so it's up to you if you want to put a 0x in the middle. It's not as important as when it's in the inside. Again, focusing on my lead terms here. So what do I have to multiply x squared by to get negative x cubed? And that would be just a negative x. And I'm going to line it up on top of my other x. Now I'm going to multiply that by everything in my divisor. So I'm going to get negative x cubed. And then positive x, being sure to line it up underneath my other like term there. Subtracting this negative makes it a positive, and then this will be subtraction here. So 2x squared minus 3x, and then I carry down that next term, which is just a 3. Let's do the process again. X squared times positive 2 will get me this 2x squared here, and then 2 times negative 1 is negative 2. Watch, I'm lining it up underneath my other like term again. Subtracting each of these. So I'm left with negative 3x plus 5 as my remainder. So my answer would be negative x plus 2 plus the remainder, which is negative 3x plus 5 over the divisor, which is x squared minus 1. Okay, a couple more practice. All right, so again, for dividing here, I would have to use long division for number 1 because I have a quadratic divisor. But number 2, I can use synthetic because I have a simple linear divisor. So for number 1, I have x squared plus 3x as my divisor. My dividend is 5x to the 4th plus 14x cubed plus 0x squared, which I'm putting in, and plus the 9x. Now it's up to you if you want to put a 0 at the end for the constant that's not there, but it's really not necessary. So 5x to the 4th, we want to see how many times can that x squared go into 5x to the 4th, and it would need to be multiplied by 5x squared. And I'm going to put that up top, right on top of my other x squared, so I can keep it organized. 5x squared times x squared is 5x to the 4th. 5x squared times 3x would be 15x cubed. And of course, both of these will get subtracted. So the first two cancel, and then this gives me negative 1x cubed. And then if I'm dropping down my next term, it's just 0x squared, or really you don't have to drop anything down. So again, now we're looking and saying, okay, x squared times what would give me this negative x cubed is just negative x. And then negative x times 3x will be negative 3x squared. Now we're subtracting. Both of these are negatives, so that's going to make them both into addition signs. The x cubes cancel, and then I have 3x squared, and I'm dropping down my 9x since that's my next term. Now I have to figure out what do I multiply x squared by to get 3x squared, and it's simply just going to be that 3. So I'm going to multiply 3 times x squared and get 3x squared. 3 times 3x is 9x. And then I'm going to subtract. In this case, they both cancel. And of course, if I brought my 0 down, I still have a 0 there. So there's no remainder here. So my final answer is this trinomial here up top. All right, so we're going to do one more division problem. This one, though, we're going to use the synthetic division. Since I have a simple linear divisor, I can just solve it using zero product property and put the -4 on the outside. My coefficients, I'm going to have a 1. I'm going to put in my 0 for the x cubed since there's no x cubed there. -16 as my squared coefficient, a 1, and then a 4. Using my grid, dropping down the 1, multiplying it to the -4, adding up that next column, multiplying by the -4 again, adding up that column, multiplying, adding up the column, and multiplying the column. So my remainder is 0. My constant is a 1. My x coefficient is a 0. My x squared is -4, and my x cubed is the x. Now, because I don't have a remainder here, I don't have to worry about that. So it's just going to be 1x cubed minus 4x squared. Again, if there's a 0 here, I don't have to put that in. So I can just write +1, and that would be my final answer for that one. All right, so now hopefully you're feeling better with this division, these two different methods of division. So polynomial division has some different applications. So if you remember, we were factoring some problems in the last section, and sometimes we got to problems where we couldn't factor anymore, or we wanted to see if there was any x-intercepts or things like that. So when we're factoring polynomials, or trying to find those roots or solutions or zeros, as we were doing in the last section, sometimes this can help us, especially when some of those answers are maybe imaginary or things like that. So, or if you just want to check and see if something is a factor or not. So when the remainder is 0, the divisor is a factor of the dividend. So for example, in this last problem that we just did, because we got a remainder of 0, we know that x plus 4 is one of the factors of this larger polynomial. So if there was a remainder, then it would not be. So this just tells us that we can divide this polynomial here by x plus 4 evenly. And when you can divide something evenly by something else, that makes it a factor. So the factor theorem says that a polynomial has a factor x minus some number h if and only if, when you substitute that number in, you get 0. And this is, it's called a 0 because f of k would equal 0. So you're substituting in that number, getting 0, so the function of that number would equal 0. So if we're to factor this polynomial given, we know that the k value makes it equal 0. So what that means, right, is that if I substitute this value in here, my remainder is 0. But the factor of this is x plus 2. So that's one of my factors. Okay, now this is a cubic polynomial. So if you remember, we should have 3 factors or 3 solutions. So at most, we can have 3 factors. Now we know one of them is x plus 2, provided that when we substitute in this -2 here, we get a 0 for the remainder. So let's see what happens when we do that. So if I take my -2 out in the front, I have 1, -5, -2, and 24 for my coefficients. I drop down my 1. 1 times -2 is -2. That adds up to -7. Then I get +14, 12, -24, and then that's my remainder of 0. Okay, so since I got a remainder of 0, that means x plus 2 is one of my factors. So now what we can do is we can do this remaining portion here, and we can just factor this out. It's just a simple trinomial. So this is x squared minus 7x plus 12. How can I factor that? X and x. What numbers multiply to 12 and add to get 7? 4 and 3. In this case, they're both negative. And then, of course, that factor that we knew from the beginning that we divided out would be the third factor. So remember I said x cubic, that should mean 3 solutions or 3 linear factors. Okay, sometimes you can't get all of them, but there definitely wouldn't be more than that. So we know that we're finished at this point. All right, so let's try the next one. So first thing they're giving us is that this k is equal to 6. So we know that one of the factors then is x minus 6. Remember, it's going to be that opposite sign. So we're going to do our synthetic division or substitution, whatever you want to kind of think of it as. We're using the regular 6, though, not the factor version, the one that's solved. Putting in all my coefficients here. And then we're going to go through the grid. So dropping down the 1 times 6, adding those up, 6 times 3, adding those up, 6 times 2, and we got a remainder here. So that means this factor is definitely a factor. So if that's a factor, then I can take my remaining polynomial here. Oops, that's just supposed to be an x there, sorry. We can take our remaining polynomial here, which is just x squared plus 3x plus 2, and we can see if it's factorable. Are there two numbers that multiply to 2 and add up to 3? There are, 2 and 1. It's a lot easier to factor something in the quadratic form than it is cubic. So now we can drop this factor down here, and our final answer is these 3 factors. And again, it was a cubic polynomial, so there could be 3 factors at most, and we found all of them. Now, this can obviously only be used if you have one of them given to you, right? So if we didn't have any factors given to us, like in the last section, we would have to do like our factoring by grouping or something else here, and you'd still get the same answer in the end. But this might just be a quicker way to get it if you're already given one of the factors. All right, so let's take a look at number 3. Okay, so again, they're giving us this k value of 10, which tells me that this one possible factor is x minus 10. So if I divide that 10 out and I get a 0, then I know that's definitely one of my factors, and I can factor the remaining polynomial to get the rest. So I'm putting this 10 on the outside, and I'm going to use my grid. So 1 times 10 is 10. Add those up, I get negative 2, negative 20. That gives me an 8, negative 8, sorry, negative 80, and then that's 0. So good. So my remainder was 0, constant x squared. So here I have x squared minus 2x minus 8 as my remaining polynomial. This can be factored into x and x. The two numbers that multiply to get 8 and subtract to get 2 are 4 and 2, and it's a minus 4 and a plus 2. And then, of course, the x minus 10 is my third factor there. Since this is a cubic polynomial, it should have 3 solutions. So therefore, there could be at most 3 factors. All right, number 4. So my first one here tells me that I have a potential factor of x minus 9. So I'm going to use my grid. I'm going to try to divide out that 9 and see if I get a 0 for my remainder, and that will confirm it for me. So I bring down my 1 times 9, negative 9. That gives me negative 81, which is, I believe, 14. And then 9 times 14, let's see, I think that's 126 actually. Okay, so now, because my remainder is 0, this is my constant, my x, and my x squared. So I have x squared minus 9x plus 14. Getting the remainder of 0, already confirmed at x minus 9, is definitely one of my factors. Two numbers that multiply to 14 and add up to 9 are 7 and 2, and it's a negative 9, so they're both negative. So those are my remaining two factors. And then, of course, included that x minus 9 there. It's an x cubic problem. I found all three factors, and that's it. So now what we're going to do is essentially the same thing, but this time we're going to find the zeros instead of the factors. So that just means after you get your factors, you're going to be solving and getting those zeros. Same concept applies. If this is a cubic polynomial, then I should have three answers. So we're going to start out basically the same. We're going to set up our grid the same way. This time they're giving us x equals. So that's kind of the same thing as giving me the k, because they're already telling us the 0. So now, if I drop down my 1, multiply by negative 5, add them up, multiply, add them up, multiply, I get a 0. Okay, so that's good. So that means this is indeed a 0. Now we already know we should have gotten a 0 there, because this time they're actually telling us, like, this is one of the answers. So we should know when we plug this in, we're definitely going to get a 0. If you're not getting a 0 for these, then you know that you did something wrong, because it's telling you given 1, 0, which means you're going to get a remainder of 0. So what we're going to use this for now is we're going to factor and solve the remaining portion. So this is now x squared plus x minus 2. So we would go ahead and factor it just like we did on the last page. The two numbers that multiply to 2 and subtract to get 1 are positive 2 minus 1. And then we have to then solve to get the remaining two zeros. So using your zero product property, you know that this is going to be x equals negative 2. This one is going to be x equals positive 1. And of course, your other 0 there would be x equals negative 5 that you had from the beginning. So you want to make sure if it's a cubic, you have three final answers, the one that was given to you and then the remaining two. All right, so let's try number 2. All right, so again, setting up my synthetic grid, I have a 1, a negative 2, a negative 9, and an 18. And I'm going to, since this says x equals 2, I can just leave the 2 as is and put it out in the front. So dropping down the 1, 1 times 2 is 2, adding those up I get 0, 0 times 2 is 0, adding those up is negative 9, multiplying it negative 18, which confirms the 0. So this is definitely one of my answers. So now I can use this trinomial that I get here, which is really x squared minus 9, and I can factor that into x plus 3 and x minus 3. Oops. Hold on a second. All right, and then that means my two solutions there are going to be x equals negative 3, x equals positive 3, and of course I have the original 0 as well that was given to me in the beginning of the x equals 2. The cubic polynomial, I should have 3 zeros or solutions, and I did. I have 2 that was given, and then I found the remaining 2 zeros, 3 and negative 3. Okay, number 3. Setting up my grid, 1, 11, negative 150, and negative 1512, and the negative 14 is going out into the food. So dropping the 1, I get negative 14, add those up, negative 3, multiply that is 42, I think. Then I have a negative 108. Of course, I don't know that one off the top of my head. 14, I'm hoping that it's going to be 1512, which it is. And then, of course, that confirms that this negative 14 is one of my zeros. So now I can do x squared minus 3x minus 108 and factor that into x and x. The two numbers that multiply to get 108, that subtract to get 3 are 12 and 9, and it's going to be a negative 12, positive 9. So that tells me my solutions are x equals 12, x equals negative 9, and then of course I had my original one that was given to me, which was negative 14. It's a cubic polynomial. I should have 3 solutions. One was given to me. I found the remaining 2. Okay, so then this one, we're going to put our 8 out front. 1, negative 11, 14, and 80. Dropping the 1 down. 1 times 8, adding those up. Negative 24, adding those up. Negative 80, adding those up. Okay, so the 8 is now confirmed. This is x squared minus 3x minus 10. The two numbers that multiply 10 that subtract to get 3 are 5 and 2, but since it's a negative 3, it's negative 5, positive 2. That means my solutions are x equals 5, x equals negative 2, and then of course the one that was given to us in the beginning, which was 8, and this is a cubic polynomial, so it makes sense that I would have 3 solutions. All right, I think we have 2 word problems left now. Okay, so let's finish this lesson with a couple word problems where we can apply this polynomial division. So find an expression for the missing dimension. Notice it says find an expression, so we don't actually have to solve it with a number per se. We're just going to find an expression to represent the missing dimension, which in this problem will be the height. So we're given a width, which is x minus 4. We're given a length, which is 2x plus 1. And we know that the volume of this box is this longer cubic polynomial here. Now, if we think about volume, we know that volume is length times width times height. So for example, if I were to just put some numerical values in there, let's say the volume is 30, and I knew the length was 5, and I knew the width was 3, and I needed to find my height. Well, how would we go about doing that? Well, most likely we would multiply the 5 and the 3 together, giving us 15. And then we would divide that 15 from the volume, and we would be left with 2, which would represent our height in that case. So we're going to do the same process, but we just have polynomials to work with. So notice the first thing that we did here was we multiplied together the 2 dimensions that we did know. So in this particular problem, that would be the x minus 4 for the width and the 2x plus 1 for the length. So the first thing we want to do is multiply those 2 together, those 2 factors, and we can do that just by using that distributive property. And then, of course, we're going to combine those like terms, so we get 2x squared minus 7x minus 4. Now, like I was showing you up here with just the regular numbers, after we multiplied together the 2 dimensions that we knew, we would take that product and divide it from the total volume to get the remaining factor. And that's what we're going to do here, except that we're going to have to use our polynomial long division. So we're going to take the product that we just got, which was this 2x squared minus 7x minus 4. And we're going to divide 2x cubed minus 11x squared plus 10x plus 8 by that product, because that is now our divisor. And then the remaining factor should be our quotient. So again, for our polynomial long division, we want to figure out, well, what is that number or term multiplied by 2x squared that will give us 2x cubed? Well, we're missing an extra x, so we know there's going to be a single x value. So now when I multiply my x by 2x squared, I get 2x cubed. X times negative 7x gives me negative 7x squared, and x times negative 4 gives me negative 4x. Now all of those need to be subtracted. If it was already a negative, it becomes an addition sign. And now I have negative 4x squared plus 14x, and I'm going to bring down that 8, and I'm going to repeat this division process again. So what's the next part of my quotient? That when I multiply that term by 2x squared, I get negative 4x squared, and that would be negative 2. So now I'm going to multiply my negative 2 to the 2x squared, giving me negative 4x squared. Negative 2 times negative 7x will be positive 14x. And negative 2 times negative 4 is positive 8. Notice when I subtract, this becomes a positive and these become subtraction, and then all three of those cancel, leaving me a remainder of 0. You have to get a remainder of 0 in order for this to be a factor. So x minus 2 then is our height, because when we divide out the product of the first two factors, we're left with that x minus 2, which would be the expression for the height. Now, we couldn't do synthetic division here because this factor for the length had that coefficient in front of the 2. So that kind of does not allow us to do the synthetic. All right, so let's take a look at this one here. So this one will be a little bit different because the width is x, which is just a simple linear factor. The height is also a simple linear factor, and we're finding the length. So again, we can still do this using the long division, right? We would have to multiply the x and the x minus 2 first, giving us x squared minus 2x. Now, if we want to do the long division, we're going to take this divisor here and we're going to divide it into our larger polynomial for the volume. And I am going to put that 0 at the end as a placeholder. So now if we do our long division, we know that x squared times another x would give us this x cubed that we need here. And then x times negative 2x would be negative 2x squared. Now we would do our subtraction, which makes this one addition. So we end up with 3x squared, and I would carry down that negative 6x as my next term. So now I'm going to be looking at my 3x squared. So I know that I would need a 3 up here in the quotient because 3 times x squared gives me this 3x squared, and 3 times negative 2x is negative 6x. And of course, when I subtract each of these, they both cancel out. And then even if I bring down my 0, it's still, I'm finished. There's no remainder. So we know that x plus 3 would be the length here. Now another option would be to do synthetic. The reason you could do it here is because you have x and you have x minus 2, which are both simple linear factors. Because really, when you have just an x, that means you have a factor of x plus 0 or x minus 0. That's why we just write x. So if I were to do synthetic here, this is just going to be divided out as a 0, and this will be divided out as the 2. So it doesn't matter. What you're going to do is pick whichever one you want. So I'm going to pick the 2 first, and I'm going to put in my coefficients, which are 1, 1, negative 6, and 0. I'm dividing out this 2. And of course, that's my remainder. So that would have left me with x squared plus 3x. However, I'm now going to divide out the 0 from that. And it's really plus 0 there, right? So when I go to divide out my 0, bring down the 1. That's my remainder. This is my constant. This is my x. So I'm left with x plus 3. That's the same thing we got doing long division. So as long as your factors are all simple linear factors, you could do synthetic and just do it as many times as you need to. So if you have 3 factors and you're dividing out 2 of them, divide out 1 synthetically, then use your coefficients of that answer, divide out the next one synthetically, and then you should be left with your final factor. You could also multiply the 2 factors together and then divide out that product using long division as well.